Section 2.6 is solving equations using multiplication or division. I can solve equations using multiplication and division. We can use division to solve a multiplication equation because multiplication and division are inverse operations, just like adding and subtracting were in the last section. So the division property of equality says dividing each side of an equation by the same non-zero number produces an equivalent equation. And there's some examples here. If I have multiplication by 3 and I undo it by division, as long as I do it on both sides, that works because 3 divided by 3 gives me just 1 times x. And I know that 1 times x is just x. So all I have left on the left side then is an x. And that works whether we're using numbers or variables. Something to remember here, though, we cannot divide by 0, so be careful there. Example 1 is solving an equation using division. Here I have -6 times x. We get rid of multiplication by dividing, and I know there's a negative in front of that 6, but it's not subtraction, it's a -6. So we get rid of that by dividing, because -6 divided by -6 just gives me a 1, and I haven't changed that x or the fact that they're equal. And as long as I did the -6 to both sides with the same operation, I get an equivalent equation. Now I know that 1 times x is just x equals -8. Now to check it, I plug it back in. I take -6 times my answer, -8, and I check to see, does it equal 48? Well, when I simplify here, negative times a negative gives me a positive 48, which equals 48. So, since those check and it's true, my solution is x equals -8. The multiplication property of equality says to solve an equation that involves division, we can use the multiplication property of equality. Multiplying each side of the equation by the same non-zero number produces an equivalent equation. So here I'm dividing by 3. To get rid of that, I multiply by 3. And again, as long as I do that to the same side, or the same thing to both sides, it's equivalent. Because here, again, I end up with 3 divided by 3. Remember, we write it over 1. Multiply across. 3 divided by 3 is just 1 times x, and anything times 1 is just itself. So, in example 2 here, we're going to solve. Well, we look at our variable. What's happening to it? It's being divided by 7, so we get rid of that by multiplying by 7. And if I change one side, I've got to change them both equally. Now, 7 times 9 is 63. I did not change the fact that these are equal since I did the same operation on both sides. I didn't change my w, but 7 divided by 7, because we started off with division, gives me just 1. And I know that anything times 1 is itself. So I get w equals 63. We plug it back in to check. I have 9 equals w, which we said was 63. Now I'm going to check it. After I reduce. So I get 9 equals 9. That checks. So we are correct. Feel free to pause here and give this a try if you'd like. We look at what's happening to our x. Right now they're touching, which means the implied operation is multiplication. To get rid of multiplication, we divide. They're inverse operations. And if I change one side, I have to change both sides of my equation. Both expressions, both the left side and the right side of that equals. 2 divided by 2 gives me just 1. 18 divided by 2 gives me 9. I did not change the fact that I have an x here or that they're equal. 1 times x gives me just x, so I get x equals 9. We want to check to see if we're right, so I take that and plug it in. I have 2 times x, which we said is 9, and equals 18. Simplify here. 18 equals 18. That's true. So since it's true, our solution is correct. A is being multiplied here. So to get rid of multiplication, we divide. Remember, that's a -5 times A, not subtraction. So to get rid of multiplication, we divide. And if I change one side, I have to change both of my equal sign. Now we're going to simplify. Negative divided by a negative gives me a positive 12. I didn't change the fact that they're equal since I did the same thing on both sides. -5 divided by -5 gives me a 1, and I still have my variable here. I can simplify. 1a gives me just a equals 12. Now we want to check that, so we plug it back in. I have -60 equals -5 times, we said a was 12. Simplify. I get -60 equals -60. That checks, so my answer is right. And we're going to do the same thing on 3. Our variable is being divided here, so to get rid of division, we multiply. That's our inverse operation, and if I change one side, I have to change both equally. 2 divided by 2 gives me just 1. I still have my variable y. They're still equal since I did the same thing on both sides, and I get 26. 1 times y is just y, so I get y equals 26. We want to check to see if we're right, so we plug it back into that original equation. Instead of having a y here, I have a 26 divided by 2 equals 13. And this is what we're checking to see if it's a solution or not. 26 divided by 2 is 13. And I get 13 equals 13, which is true. So our solution is correct. And finally, number 4. B is being divided by 8. To get rid of division, we multiply. It's our inverse operation. 8 times -8 gives me a -64. I didn't change my equal sign. I didn't change my variable. But 8 divided by 8 gives me just 1. Now, b times 1 is just b. Anything times 1 is itself. So I get -64 equals b. We want to plug it in and check. So I plug it back in my original equation. -8 equals, I see a b, which I know is a -64. And I'm still dividing it by 8. That part didn't change. Now, we simplify. Negative divided by a positive gives me a negative. 64 divided by 8 is 8. So -8 does equal -8. That checks, so my solution is correct. On January 4th, 2003, a spacecraft detected solar wind traveling at about 2 million kilometers per hour. The sun is about 150 million kilometers from Earth. About how long did it take the solar wind to reach Earth? So here we have to use a formula, and that formula that we're going to use is our distance formula. This you're going to want to know. Distance equals rate times time. Very common formula, very helpful in life. For example, if we know we need to go to Sioux Falls, we know it's, I don't know how far Sioux Falls is, 300 miles, let's say. I don't know. And we know that we can travel 80 on interstate in South Dakota. How long does it take us to get there? What time do we need to leave? Or if we need to be somewhere in, or we're trying to travel on a road trip, okay, and we know that we can average 65 miles an hour, we want to drive 7 hours a day, how far can we get? Where do we need to get hotel rooms? So things like that. So here it says the wind was traveling at about 2 million kilometers per hour. That is our rate. So this is 2, I'm just going to write out million for now. Kilometers per hour. Then it says the sun is about 150 million kilometers. That's our distance. We are looking for how long. That's my time. So I'm going to keep that t since that's what I'm looking for. Now, since both of these are in million and million kilometers, I don't need that part. So what I really have here is 150 million kilometers equals 2 million kilometers per hour times t. T is being multiplied by 2, so we divide by 2, and if I change one side, I change both. Here I get 75 equals 1t, or just t, and that's going to be hours since my label was in hours. So 75 hours for that solar wind to reach Earth. And that's all I have for section 2.6.